Hey fifth graders, we are going to be jumping into our multiplying fractions unit, and we're going to start off with multiplying fractions by whole numbers, and we're going to start off by modeling how to solve these problems. Now there will be a shortcut, and you're going to love the shortcut, and moving forward we will use the shortcut, but I really want to model what's happening when you multiply fractions by whole numbers so that you can understand why you get the answers that you get, because what you're going to notice is that your whole numbers will end up getting smaller because you are going to be taking part of a whole thing because you're multiplying your whole number by a fraction. And we're going to use some knowledge that we already have, and this is some knowledge we already have. Recall that multiplication is repeated addition. Now, we already know how to add fractions, so we can already understand how to multiply fractions by whole numbers by repeatedly adding the fractions together. Also, we know that multiplying by a whole number, it tells you how many sets of the other number you have. Now, I'm really emphasizing the word of because of is a small word with a big meaning. Of in math means to multiply. Multiply. Sets of. When you take half of something, you are multiplying it by the fraction 1/2. If I'm taking 3/4 of 3/8, I'm going to be multiplying those together. Of means to multiply. And we can use this to help us multiply whole numbers by fractions. So let's go ahead and take a look at the meaning of 3 times a quarter. So really what this means, if I translate this, this means I have 3 sets of, multiply, a quarter. So let's draw a picture of 3 sets of a quarter. So I'm going to create quarters first. That's a little off, but here's one set of a quarter. Here's a second set of a quarter. Here's a third set of a quarter. So in all, I have 1, 2, 3 quarters, which is my answer. We can do this by using repeated addition as well. So we can go ahead and say, okay, I know when I multiply 3 by anything, what I'm doing is I'm taking 3 sets of that thing and I'm adding it to itself 3 times. And again, that ends up giving me 3 quarters. Okay? Let's take a look at another example. 5 times 1/3. Well, this literally means you have 5 sets of multiplication of 1/3. So let's draw a picture of 5 replicas of a third. So here's 1/3, here's another set of a third, another set of a third, another set of a third, and another set of a third. That gives us a grand total of 5 thirds that are shaded in. 5 thirds is equivalent to 1 2/3, which will be our answer. Let's go ahead and use repeated addition. So this means that I have 1/3 plus a third plus a third plus a third plus a third. I do that 5 times. And I get 5 thirds, which is equal to 1 2/3. Okay, now some of you, might be realizing, oh, so do we just put that number in the numerator? And the answer is no. We're going to take a look at what happens when I don't have what's called a unit fraction. That's called a unit fraction. And here I don't have a unit fraction. This means I have 4 sets of, multiply, 3 quarters. So let's create quarters. I'm going to shade in 3 quarters. That's 1 set of 3 quarters. That's another set of 3 quarters. Here's my third set of 3 quarters. That's my 4th set. I have 3, 6, 9, 12 quarters in all. 12 divided by 4, because that's improper. That's equal to 3 whole things. I can solve by using repeated addition. So that's 3 quarters plus 3 quarters plus 3 quarters plus 3 quarters. I do that 4 times. I get 12 quarters, which is equal to 3. Let's take a look at how we can model this with number lines, because number lines are also a really terrific visual model. So we can use our skip counting skills to help us to solve multiplication problems dealing with fractions. So if I have 5 times 1/3, we're going to skip jump by 1/3 5 times. So here's my first skip jump of a third. Here's my second. Here's my third. Here's my fourth. Here's my fifth. Now let's label down here where this is living. So that's my answer. So this is 2/3, 3/3, 4/3, 5/3. That's 1, 1 1/3, 1 2/3. So our answer would be 1 2/3. We can model what 4 times 2/6 is by doing 4 skip jumps of 2/6. Well, if this is 1/6, I need to do a skip jump of 2 tick marks. 2/6. Now let's see what number that is. So I have 1/6, 2/6, 3/6. 8/6 is equivalent to 1 2/6, which is equivalent to 1 1/3. And that is my final answer. Now let's take a look at another way, one more way that we can model multiplying fractions. So we have a real firm understanding of the meaning of multiplying fractions by whole numbers. So sometimes our fraction is going to come first, and that means you're taking a portion of a whole thing. Multiplying a fraction by a whole number represents taking part of the whole amount, because this is part. To multiply is of a whole. So you're taking part of a whole. You're taking a portion of whole things. So we're going to find 1/4 times 20, which means taking a quarter of 20. So if I need to create quarters, I need to create 4 equal groups. And I see 4 nice equal columns here. And I'm going to take one of them. So I'm going to take one. So I'm going to take one of these guys, and that is indeed equal to 5. 5 is a quarter of 20. If I want to find 3/5 of 10, well, I'm going to break up 10 into 5 equal groups. And I'm going to take 3 of those groups. So I've got my 5 equal groups here. 10 divided by 5 is 2, and then I'm taking 3 of those. And I end up getting 1, 2, 3, 4, 5, 6. 6 is 3/5 of 10. So let's talk about the meaning of numerators and denominators. When you're finding a fraction of a whole, you break up your whole into the number of groups as indicated by the denominator. Then take the number of groups as indicated by the numerator. So again, so the denominator tells you how many total equal groups to split it up in. And then the numerator tells you how many groups to take. Okay, so we're going to do this step by step and create visual models of what it means to take portions of whole numbers. So we have 2/3 times 6. That means I'm going to take 2/3 of 6, because again, of means to multiply. So we're going to break up 6 into 3 equal groups, because that's what our denominator tells us, and then we are going to take 2 of those groups. So I see 1, 2, 3 equal groups, and I'm going to take 2 of these equal groups, and that gives me a grand total of 4. 4 is 2/3 of 6. We have 3/8 of 16, 3/8 times 16. So what we're going to do is we're going to break up 16 into 8 equal groups, and we will take 3 of them. So we've got 1, 2, 3, 4, 5, 6, 7, 8. There's 2 in each. And we're going to take 3 of these. Because I've just taken 3 out of 8 equal groups. So I've taken 3/8 of this whole thing. And that is equivalent to a 2, 4, 6 as well, coincidentally. let's create our own diagram. So if I'm taking 3/4 of 8, I'm going to break up 8 into 4 equal groups, and then I'll take 3 of those equal groups. So I'm going to create 8 things, and I'm going to split them up into 4 equal groups, which means there's 2 in each, because 8 divided by 4 is 2. And I'm going to take 3 of these groups. That gives me a total of 6 yet again. Man, 6 is popular here. That's a coincidence. Let's take a look at 1/6 of 18. We're going to break up 18 into 6 equal groups, and we will take 1 of those. So I'm going to go ahead and create my 6 groups. 1, 2, 3, 4, 5, 6. And I know I need 18 in all of these. Or excuse me, I need 18 in all, which means I need 3 in each, because 3 times 6 gives you 18. And now I'm taking one of these groups, and I get 3 is in that one single group out of 18.